Alright, hey guys. Same kind of updates as before. I'm gonna do something different. But I'm, waiting on Social Security. It's been 36 and a half years. Most recent case pending. Still pending. I left my job November 8th, 2021 in the digital print industry as a press operator, and Social Security was applied a year later. I was in so much pain I couldn't even pull myself to apply. It took me a year to get the right frame of mind to actually fill out an application online. So it was November 2022 that I applied, and it is January, almost February 2025 right now, and no response from Social Security. My case got denied. My case got denied for no reason at all, and it got moved to a court hearing, which was done on the phone. Yeah, that was back in October 2024. It took that long just to get a hearing, and it takes 2 to 3 months after the hearing to get a decision from the judge, according to the Social Security Administration. So we'll say 3 months is November, December, January, and we are beyond the 3-month point here at the end of January. So that's the update. No response from Social Security. My response would be, if you don't approve this case, I will have you killed. That's my response. But today I'm going to talk about something different. We're going to talk about the Xerox Igen family. I'm just going to introduce you to the press. I'm out here in the wild. Obviously there's no Igen press out here, but we're going to have to do, I don't have one at home, so we're going to have to do the best we can. So this press is the Igen4 that I'm talking about. It's the best one. It's improvement over the Igen3, and beyond the Igen4, it's not really that much of an improvement. But I'm going to tell you how to operate the press. It takes months to years in order to learn how to operate the press. Years to get good at operating the press. Months to learn how. And that's best case scenario. So we got to get started, because it's already been several years since I've been in the field. The field is going down the tubes. Again, I own the field now, so I'm just going to share with YouTube, the viewers on YouTube, how to run the Xerox Igen press. This knowledge is not going to be shared by Xerox. It's not shared by Xerox. It's not shared by the print companies in the industry. This is shared by me only. And that's because they don't know what I know. So we're going to start with basic training. I have a lot to get through today, but we're just going to start going. So the print field is, also known. Print production is where you are creating things that weren't there before. Paper comes from trees, probably bigger ones than that. And there's a whole process into producing and manufacturing paper, but the print industry is dependent on paper, right? If we're not printing on paper-like products, we have no business at all. So the Igen is engineered to accommodate many different types of paper, and it's a pretty good press in terms of the engineering. There's some things that I would change, but overall it's a pretty good press, and it has a very broad range of capabilities, and it can do large volumes of printing consistently with not really all that much maintenance required. Obviously, everything depends on what you are printing. Some things are just simply more difficult to do than other things. But I'm going to introduce you to the press today. Print industry, just a brief overview of printing. You have pre-press, you have press, the actual printing, and then you have finishing, and then whatever, shipping or delivery or whatever after that. So before it gets to the press, you have files that are either created by the customer or provided by the customer or created by the print company. So graphic design, right? So you can make images, you can make files that are going to be sent to the press, print ready for the press to begin. So the operator, which is me, has to worry about operating and maintaining that press and turning the file into something I can hold, into a material that looks pretty damn good. Whew. Sorry I'm out of breath. I'm not in shape, but we'll get there one day at a time. Okay, so that's the print production process. So here's the press. I'm talking about the Igen4 today. As you can see on your left, we're looking at the press on your left. You have three different sections of this press. You have the feeders, you have the print engine, and you have the finishing. So in this case, this is a standard model. There's no extras on this model. It comes with two feeder units with 4 drawers total. Your print engine, and then you have one stacker unit, which is part of the finishing area. So the feeder unit is what holds the stock, the paper, and it can go up to a max size of 14 1/3 by 20 1/2. So this press is not a monster of a press in terms of the paper size that it can accommodate, but it can accommodate roll fed stock if you choose that option. But the maximum width is 14 1/3 inches, which in millimeters is something, I don't know. You have to ask somebody else. I'm American, goddammit. So we're going to start with the feeders. I'm not going to show you how to load the feeders. I'm not showing you maintenance on this machine today. I'm just going to introduce you. So we have the feeders, 2 uppers, 2 lowers. And what happens is You know, there's a air blower, there's a heater unit, which sometimes is disabled, and then there's a suction that pulls one sheet out at a time and then carries it into transport units, which are made up of rollers that are motorized, and these drive rolls will carry the sheet throughout the press in what's known as the paper path. So I'm going to take you through the paper path. After the feeder unit, you can see to your right, I've taken all the doors off so you can see, but the first door on the top here is area 1, right? So area 1 is has no function. It is a transport only area, meaning that it carries the paper from the previous area to the next area. Previous area being the feeders, the next area being area 2. Area 2, so the paper moves into area 2. Area 2 is a unique area. It's actually on a slant, a diagonal, which is the only area in the print engine that does that. And it's a unique area called the registration area. Is made up, it has sensors that measure the sheet or look at the edge of the sheet, and it has steering, special rollers that have the ability to steer a little bit to the left or right, I think, depending on the positioning of the sheet. So it wants to know where is this sheet coming down, because the drive rollers, the primary engineering carries the sheet. It's pretty consistent, but there's some play there. And the registration area wants to know exactly where it is because it wants to prepare for transfer, which is where it puts the image on the paper. So it needs to know where the paper is exactly so it can put the image on exactly the right spot. Because it would be pretty useless if you were printing things. It would be pretty useless if you were printing things and every sheet of paper that you printed was not in the right spot on the sheet. That would drive you nuts, wouldn't it? Okay, so that's area 2. Plate and glass, lens, mirror, and a bunch of sensors in there, registration sensors. And that takes you in between area 2 and area 3 is where transfer occurs. It's not labeled as anything, but it's the transfer area. The sheet passes underneath. You have a transfer detact charge, and you have a little stab blade, they call it, a strong transfer assist blade, which kind of lifts the sheet just kind of delicately, holds the sheet where it holds the sheet in place. And magic is occurring. Magic is occurring using electromagnetic stuff, science, called science, that takes the image and puts it onto the page. And we'll show you later the components of the print engine, the imaging area, where the magic of xerography occurs. But right now we're going through the paper path. So now we have image on paper, and the paper is now entering area 3. Area 3 is another unique area. It's a transport only area, but it's different from the other ones. There's no baffle on top holding it down, no guides. It is a vacuum suction through these holes on a belt, on these drive belts. So there's actual drive belts and a little bit of vacuum suction keeping the sheet in place. So it takes it into area 3 is also known the pre-fuser area. It takes it into the fuser, which is area 4. So there's sensors in every area making sure the sheet is there and it's within, the right timing. But we go into area 4, and that's the fuser area. So the fuser, we'll show you that later. So what's happening is the sheet now has an image of dry ink on top of the sheet, just resting there. It's not like wet ink where the sheet is absorbed into the paper. This is dry ink, so it's actually just sitting on top of the paper, and it's waiting to be fused at this point. So the pressure and heat is what melts the plastic bits of toner onto the piece of paper. So you have a bunch of rollers. You have the fuser roll and the pressure roll, and the fuser roll is heated and is coated with oil, fuser oil, which is silicone-based oil, and it keeps the paper from catching on fire, I guess. But the fuser rolls are up to 350 degrees Celsius in temperature, so it's hot. And the two rollers can press together, and the paper slides through with melted toner bits on top of it. And now the image is fused to the paper, and that process is complete. So now it has to determine whether or not this sheet of paper is simplex or duplex, meaning is it one-sided, or is there another side that needs to be printed. So the sheet moves into area 5. Area 5 is made up of two parts. It's 5A and 5B. 5A means there is no duplexing required. Either it's already been done, or it's not a duplex job to begin with. And 5B is for duplex. So 5B is when the sheet, what happens is a valve or gate opens up and the paper goes downward and it curves upside down. And it moves into the duplex paper path, which is on the bottom of the machine. And then if it's done, it moves on to area 9. So it goes from 5A to 9. But we're going to assume that this is a duplex job, so we've already fused. Now we're moving into 5. Area 5, it's asking the computer, is this duplex? Does it need to go around again? Yes. Okay, opens the gate, goes down 5B. And everything in the duplex path is transport. Area 6 underneath the fuser is a transport only. Area 7, transport only. Area 8 transports and inverts the sheet, because now the sheet has to come back up to the top. And right now, side 2 is face up, as it is just duplexed. But we want that to stay that way. But if we curve it back around, then it's going to be the other way. So we don't want to curve it. We want it to stop and then come back up. I don't know what you call that. So that it stays the way that it is. Actually, the lead edge will change. So that's what area 8 does. It inverts the sheet back up to be re-registered in area 2, and the sheet goes through that same process again. Area 2 is checking for where is the sheet, how do I adjust the sheet, and then it transfers the sheet, and then it fuses the sheet again. Now it doesn't need, it's already run through twice, it doesn't need to be duplexed again, so the gate is closed and we go from 5A into 9. 9 is another transport only area. It does have some blower fans up top to help cool down the sheet after it's exited the fuser, because it's pretty hot in there. But there's also, between area 9 and 10 is a decurler roller. What happens when you fuse sheets at high temperature or high amount of pressure is you can put some curl into the sheet, and that's no good. You know, you don't want excess curl in any printing environment, in any machines or anything. Generally speaking, curl is a bad thing. A slight curl is acceptable and sometimes advantageous, and generally concave down, curl going downward is what most machines prefer, but some of them actually would go the other way. But too much curl is bad for everybody. So the decurler roller actually helps to eliminate excess curl coming out of the fuser. So that's the function of that. That's in between 9 and 10. So the sheet is getting decurled, is entering area 10. And area 10 is guess what? It's another transport area. You can see in here there's a scanning device called the ILS, or the inline spectrophotometer. That is not used in the printing process. It's used for color maintenance, which is a maintenance procedure for measuring color densities. The machine is trying to recalibrate to the correct density, so it knows, you know, it knows what voltages to use and all that stuff. It knows it has to make adjustments to get the color to be the right color, because parts wear, degrade over time, and that impacts the color density, and that's no good. You want, when you're printing a color, you want the color to be the right color. Say, well, it's the right color on the computer, but then I go to print it, it comes out bad. Or I've printed this and it looked good, and then I printed it later and it looks bad now. But it's the same color toner, so what's going on? Well, that's part of the responsibility of a print operator, is making sure things are correct. You know, doing the necessary maintenance, and, you know, observing to make sure that things are where they're supposed to be. And we'll get into all that training later. Right now we're just going through the paper path, just getting to know this press. So 10A is actually, there's 4 parts. There's 10A, 10B, 10C, 10D. And C and D are used to invert the sheet, just like in area A. But this is for the output. So after 10A, after 10, there is no more units in the print engine. It goes on, or no more areas in the print engine. It goes on to the finishing unit, which in this case is a stacker. In most cases it's just a stacker, but you have the option to have other finishing attachments on when you make an agreement with Xerox or whatever. If you do business, there are other machines that can hook up to this machine for other types of finishing. We're not getting into that. I'm just talking about the stacker. So area C and area D invert the sheet. So it goes from these are not used unless the sheet needs to be inverted. So there's a setting. There's a setting on the print job. You say, well, I want it to be face up or face down, right? The default is the way the paper travels anyways. You know, it prints from left to right, and then it duplexes, and then it comes back up. Right to left. Right to left, duplexes, comes back up, right to left again. And then that's the way, you know, then it curves one more time. into the stacker. It depends on your finishing unit what the orientation of the sheet might be. Even the top tray, I think. No, I think the top tray would be the same, I think. Yeah, I think the top tray is the same as the stacker, but it might be different for other things. So so you may need to change the orientation to face down, and if you do that, then the sheet will have to get inverted one more time before it enters the finishing unit, and that's what 10C and 10D do. But if you don't need to use them, you won't use them, and it'll move on into the finishing unit. In this case, we're talking about a stacker. A stacker / top tray. So you have a top tray which can hold, a few sheets. I don't know. It depends on the type of stock, but it can hold maybe 50 sheets. But I would only print maybe 10 at the most. You really want to stack things. You got a stacker, use a stacker. The top tray doesn't jog everything nicely. There's a lot of static usually, and there's, the stacker is more practical, but there are times when you need to use a top tray. The stacker might be broken or something. You may need to improvise. So the stacker is made up of 3 areas, 1, 2, and 3. Area 1, transport only. Area 2, it decides whether to go to the top tray or area 3, which moves to the stacker. Or there's an option that it moves to bypass and exits the stacker unit altogether. So depending on the setting, top tray, stacker, or bypass, it will decide where to go in area 2. So either it goes up to the top tray and now you're looking at the sheets printed out in front of you, or it goes to area 3, which is a stacker. The bypass setting is not usually an option, because you just don't have any other unit attached to the stacker. The stacker is the end of the line, so you won't have a bypass option typically, but it's a possibility. If you have nothing attached to the bypass, if you have nothing attached to the stacker, and you select bypass, it's literally just going to fly out, and the paper's going to fly out the press, and there's a cover on there, so it's actually flying into the press. That's no good. You don't want that. You do not want that. So that option is usually disabled unless you need it for whatever reason. So now we're entering area 3, which curves downward, and in area 3 we have a static eliminator bar, active static eliminator, and that does what you would think. It reduces the amount of static buildup. There's a lot of static buildup in this machine, and static is the enemy. The static is a real problem in printing. So if you have too much static, you have lots of problems. In this case, the stacker needs to be able to stack the sheets of paper square, nice and neat. And it's engineered to do that, but if there's too much static buildup, then sheets are sticking to the metal surfaces, or they're sticking to the paper, the sheet before it, and it doesn't jog up. It doesn't want to jog up. And then you have sheets all over the place, and that's no good, right? That's frustrating, and it's not easy to correct because the static doesn't go anywhere. It stays locked in these sheets for hours. So yeah, so this is they have a static eliminator that in my experience it does reduce the static, but it's not a cure for the static problems. But everything depends on your environment, the where your press is located. The press itself has its own environmental controls, humidity and all that stuff. But if your press is in a room that is, wildly not controlled, and you're susceptible to the change of seasons, like here we got snow in the winter, it's dry, it's cold, humidity is very low, and it can get really low. And if the building you work in is not climate controlled, then you're going to have a dry environment, which is bad for the press. It's also bad for the paper itself. So you can have this dry, cracked, brittle paper that is not very flexible running through a press, which runs on electromagnetism, and it also has metal surfaces that transport the paper. If static is building up in the machine as it's running, then you're going to have many potential problems that come from that. So it's something, having running this press in a nice environment, climate controlled environment, makes life so much easier as an operator. But if you don't have that option, then you have to be on your best game. You have to know this press well in order to be good at this job. Otherwise, it can be very frustrating. A lot of headaches, a lot of swearing, a lot of I don't know why this is happening, but there are reasons, and you can learn them, you can figure them out. Here I'm training the best of the best, so I'm going to tell you how to be a good operator. I'm not going to waste your time like Xerox does. Say, we'll certify you with 2 weeks of training or whatever, and say, oh well, that's good enough. I don't do it that way. I actually tell you how to run this press. And it does take time, It takes months to learn how to operate this press. And it takes years to get good at operating this press. But, the sales team at Xerox will tell you that it's easy to run this press. And even the CEO of Kodak is telling people that it's easy to run this press as a means for selling the press. They're telling the public that, digital printing is much easier than traditional offset printing. It's easier to operate. And then people like me who are doing the hard work operating, it's like, what the heck? It's like, how do you know that? You didn't even ask me. You didn't ask me, you didn't ask anybody. And the offset operators that I talked to said they would never run my press because it's a whole other animal. It's like apples and oranges. You're not even talking about the same thing. They're both hard to run. You have to develop skill before you can really get good at it. And then once you got everything settled and you're used to handling, the range of work that is required of you, then you can say, well, for me it's easy. I got it down, But it's not. For somebody to say that, while I'm asking for more money and being denied more money, and this guy's making $6 million salaries a year or whatever, it's just like, it's a slap in the face. So again, what I had to do at that point was buy the print industry and put it in my name, because that's unacceptable. It's already a rigged path, and for you to go and do that, it makes my life harder when you continually feed perception of what my job is when no one really knows. I'm trying to ask for money and they treat me like I'm, replaceable. So I find that insulting. So I'll train everybody myself. And I don't care whether Xerox or Kodak exists. I mean, we don't need it for humanity. We have serious problems in this country, and printing is not one of them. It is a problem, but it's not the most severe problem by any means. So yeah, that is a printing press. So we've entered area 3 in the stacker. Now the sheet is stacked. I'll just finish this off here. So the sheet is now stacked. There are some drive belts that carry the sheet onto the stack, and a little guidance joggers or whatever that hold it in place nice and square. It doesn't always work correctly. It depends on environment. It depends on the components. The belts can wear down, static buildup, toner gunk buildup on the rollers and stuff. These can degrade function, performance. So but this is all stuff that you have to be aware of as an operator, and that it's not common knowledge. Xerox doesn't do that for some reasons, I don't know. So okay, so let me see. So the paper is stacked. If you want to unload the stack, you press this here button, and elevator drops the stacker, and it's connected to this metal handle here, and you can just roll it. It's on wheels. You just roll it out, and there's your printed product. 1,000 sheets, 2,000 sheets, and hopefully they all look good, right? Sometimes you want, as an operator, you set up a job, you have all the settings right, you print out a few sample sheets, we call them proofs, and you inspect everything, it looks good, and then you run 1,000, 2,000 sheets, you drop the stacker, and you realize, oh my God, 90% of the stack is garbage. It's all bad, right? And that is it's a nightmare that happens very commonly in the print industry, and that's because the training was lacking severely. But these problems are preventable, and there are certainly ways to prevent them. And for something where you're producing paper, or you're producing image on paper, waste is your enemy, right? Waste is the thing you have to minimize. So the amount of paper wasted, toner wasted, and of course the components of the machine, the consumables that have to be replaced on a regular maintenance schedule. You don't want to just keep throwing things away, which is what happens now in the print industry. Is the consumables, the parts that are required for operator maintenance to be maintained or replaced, are wasted at a very high degree, and that's because the operator doesn't know what the source of the problem is and just puts a new part in as a way to solve the problem. And it may or may not solve the problem, but oftentimes they don't correct themselves. Oftentimes they don't correct themselves when, part of the troubleshooting process for getting an image quality artifact to go away is to just start changing parts in the machine. Say, here's a new one, here's a new one, here's a new one. Here, how does that look? And a lot of times it goes away and you go, okay, whatever, I just changed a bunch of things and it worked. And then you learn, I'll just do that every time. But you don't know why the problem got solved. The other thing is I changed a bunch of things. I changed a bunch of parts. It didn't solve my problem, but I'm not going to swap out and put the old ones back in because I already went to the trouble of putting the new ones in. I might as well leave them there. It's going to need it eventually, right? These are poor logical choices when it comes to operating the machine and eliminating waste. Now, the way the agreement between the customer and Xerox is structured usually is, I believe, is, if not always, I believe is that if you have a service agreement that Xerox provides the parts, the consumables for free, and the customer is, the operator is responsible for replacing most of them, and then the service technicians have their own serviceable parts that they do maintenance or replacements on when they are due. So that's how it's supposed to work. So actually, it's advantageous for a print company to just take advantage of the contract, which is, I don't care about how many parts you waste, just don't waste my time, don't waste my paper, my even the ink is paid for, so they don't care about the ink. Don't waste time, don't waste paper. Right, that's what the print companies care about. So it's actually advantageous to instruct the operators to waste more material, waste more Xerox material. And it's all bad for the environment, right? It's all things, I mean, what do we do with all this waste? We already have environmental concerns and problems, and this, we're not solving the problem by creating things that we don't need to begin with and then wasting them. But that is the business of printing. But printing is unique because it's a way to deliver a message. It's a way to convey information. Of course, you're doing it on innocent trees. I don't think they had much consent in the process. So, how can a tree consent? I don't know. I don't have the answer to that, but I'm just saying it's a living creature just like us. And we cut it down and then we put stupid images on it just for fun. Well, I don't know. This is what I did. My career of printing has been a long, painful career. But probably 95% of the stuff that I printed was just trash. Just spam. Just mindless spam that is that I personally take. I wouldn't do it. I personally take offense to. So I don't think it's a good thing that we use this stuff for these things. But that is what is happening. But the capabilities of the machine extend far beyond what the print industry is using it for. So, you know, I introduce you to this press because it's actually a pretty nicely designed press, and it can do a lot of cool things that most people are not doing. Most people are printing things that we don't need, and sort of you know, junk information, advertisement, marketing spam, shit that we don't need. And you know, it really is, it's a shame, you know. It's a shame because people doing these print jobs are often stressed out, and there's a lot of pressure to perform at something that is never really taught to begin with. And I know all about that, so it's enough to drive you mad, and it's no way to treat human beings. So we are sorry, rambling quite a bit. All right, so we've got everything stacked. Let's finish this real quick. So in the back of the machine, speaking of waste, we have waste containers. One of them is for the toner, one of them is for the developer. And I didn't show you those parts. I'll show you that in the next video. So developer is it's a combination of, I think it's like powdered steel. Shit. Oh, visitor. We have a visitor. We have a visitor. Developer is a combination of powdered steel and toner, I think, and toner is plastic. So I think they separate the waste materials just for environmental reasons. It's just easier to keep things separate. But these fill up fairly quickly, and the waste containers are returned to Xerox for, I don't know what they do with the waste material, but presumably they do something. Hey, when they send visitors to my videos, they always try to do this. Every time I do this, there's somebody coming in here. But honestly, these parks and stuff are relatively untouched compared to the population of the state. And as I said in my last video, I own this state. I own the state of New York. So, I mean, most people stay indoors, they watch Netflix, play video games, and work meaningless jobs for pay. And, you know, it's, if you really take a step back and look at it, you know, you'll see that it's really stupid. I mean, when you think about the potential of humanity and what we're actually doing with that potential, it's pretty sad. But so you have waste developer, you have waste toner. They get You just put a new empty bottle in there and it fills up. It has its own mechanism for vacuuming out and dropping through tubes the waste material. And there's other filters and stuff for the environment to help catch a lot of that excess toner and developer material that's free flowing in the machine. It's just floating around. You know, it has to be a clean process, but it's not exactly clean. The filters help with that, but you know, the longer you have your press, the more buildup there will be. But you can always clean it. I mean, you can vacuum. Take the time to vacuum. Will go a long way toward maintaining long-term health of the press. But you know, a lot of times cleaning maintenance procedures are neglected by both Xerox service technicians and the operators themselves. A lot of things are neglected, but cleaning is one of them. You say, well, it's not really needed, but it does. I've tested a lot of things, and it does cause problems, especially static buildup and stuff. Like if you take the time to clean all the rollers, system cleaning is what Xerox calls it. It will reduce static interference, and you'll have better functioning. And you can have jams. They can cause jams and stuff. So, yep, that is the introduction to the press. Without going into the xerographic area of the print engine and the fuser area. There's more components in there. They're more complex, but and there's a lot to learn. But that's what we will get through over the coming weeks and months. And yeah, that's the Igen4. It's a pretty good press. Quality is acceptable. It's it could be better, but it's really good at doing large volumes and maintaining consistency without a lot of downtime necessary due to operator maintenance and stuff. So I think it's probably the best press that exists in digital printing. But I haven't tested them all. But I would say that's probably the best one, just because from the standpoint of a print operator or from a print company, you want to be able to get as much done as possible without compromising quality. But sometimes you don't need that, right? Sometimes you just want to get things done that look good and you don't want mistakes. And if you're really quality conscious, then I would pick a different press. Because, you know, the look and feel of things, it's not that good. But you know, for the average person, it's pretty damn good. It's impressive. It's an impressive press. Impressive impressions you made there on your press. Well, yeah. At least I'm not out of breath anymore. But I will. I'll keep you updated. We'll do more training later. we'll do more training later. We'll talk about the fuser. We'll talk about the print engine, the zero graphic components, and then we'll move on to maintenance procedures. Oh, no. Before that, we'll get into the software. We'll talk about programming jobs, programming stocks, and setting up jobs, and then we'll start printing the jobs. You can see the press in action. Having these concepts will allow you to operate the machine better, because you will have problems and you will need to know how to troubleshoot these problems as efficiently as possible. So having a conceptual understanding of how the press even works to begin with really helps. It really makes, I didn't have that when I was learning, is a lot of this stuff was kept in the dark, and there was no information provided from Xerox. So you had to learn trial and error style, which is never very efficient. So and then being under the stress of people yelling at you, saying this has to go, what's going on, why is the machine down, why is the green light off, right? Why is this not running, what's going on? And I have to explain myself. It's like, well, I don't know, there's a problem here, I'm trying to figure it out, but you're interrupting me, and I don't need extra pressure. I already have stress in my life. I don't need this. So I'm just trying to learn how to do this job, and nobody taught me. You're just yelling at me. So I'm not new to that sort of behavior, but it's wrong. So it shouldn't exist, in my opinion. But having these concepts is going to help you, but hands-on learning is the best way to learn. So I'm just throwing stuff at you now, and then we'll move on from there. Once we learn the software a little bit, you'll learn how to set up jobs and release jobs, and then we'll start watching the machine run, and we'll start we'll wait for things to go wrong, and then we'll say, what's going on here, and I'll show you maintenance procedures. There are ways to do things. Some ways are better than others. Some ways are not very smart. A lot of shortcuts are taken, and a lot of waste is happening because of the shortcuts. And I'm not saying you should take your time, be slow. I'm saying do it right. I'm saying know what you're trying to do and then do it. Because you're trying to minimize problems, you're trying to minimize errors on the machine and stuff. So minimize waste, maximize productivity without compromising quality. That's the name of the game, baby. All right, so I'll see you next time, and we'll go from there.